Have you ever wondered how a multimeter works? Well, I'm going to try and explain the basics to you. I'm an electrician of 20 years and I've had several multimeters in my life, but the Fluke, the standard Fluke 100 series, good solid multimeter, you do pay a bit of extra money for them. There are multimeters for £10 or less available out there, which will work fine if you're a hobbyist. But as I use this every day of my working life, the Fluke is the one for me. Other brands are available, but we're not the BBC, so it doesn't matter. Okay, I'll try and keep it in frame if I can. So this multimeter is one of the more basic ones, but it is true RMS, as they say. What does that mean? Well, it doesn't really matter for this video, but if you want a good multimeter, generally, you want to see that it says true RMS. Okay, this multimeter has multi-functions, multi-settings. That's why it's called a multimeter. It runs off, I think, a PP9 battery, 9-volt battery. It has a backlight that you can use for when the light isn't so good, when you're in those dark cupboards under the stairs trying to investigate things. This will also measure, so let's go through the dial. You can measure voltage AC, voltage DC. They're indicated wavy line for voltage AC and line and a dotted line for DC. Millivolts, resistance. This is resistance with a tone out. That's what that little signal means, the little sound signal. This is diode check. And then amps AC, amps DC. Now, I've got to be honest, I never use these for amps. Not on a 240 volt system. Tend to use clamp meters for that. They're a lot more reliable, safer, easier, because when you use amps, you've got to go in line with the supply, not parallel with it like you would for voltage or resistance, which can cause lots of problems if you don't really know what you're doing. Okay, switch the machine on. Tells us the model number, tells us we got some voltage. Well, we know that's not true because nothing is connected. Generally, these meters will never read zero. You can zero them out if you wish. And when you always switch them on, almost all meters will automatically default to, let's try and get that on the camera, auto. And what that means is it will auto range. So if I'm measuring 10 volts, it should display 10, but when I get up to 2000 volts, it will move the decimal point automatically, so the reading will fit on the screen. You lose some of the decimal places, obviously, so it's not so accurate, you know that word. But a good test device if you're any sort of electrician. We've got some other functions here which should work on most settings. So hold will just freeze the screen. Min max. It's now monitoring for its maximum input, minimum input, and it records those temporarily while the machine's switched on, so you can flick back and forth between the min or max range like that. And then this one actually does average as well, which is quite good, but we won't need that, so I'm pretty sure we just hold that down and it clears, goes back to auto ranging. Range, so this switches it to manual or auto, and then gives you the decimal places it will read to in this little lower display here. I'm afraid using my camera phone that's not showing up as good as I'd like it. But anyway, there's the backlight. Let's see if you can see the backlight. See, there's the backlight. Oh, let's switch my light back on. There we go. Now, the annoying feature of these models, quite a lot of the Flukes do it, is that backlight doesn't stay on. It goes on for about a minute and then switches itself off. Very annoying. And this meter also has some secondary functions activated by the orangey yellow button here. So if I was to press this button while set to V, it will start reading frequency. On the millivolt settings, the yellow reading, the yellow function would be DC millivolts. And then if you can see it down here, the diode settings becomes a reading for capacitance or capacitors. Now that's quite interesting because it takes a bit of skill to use that one, because capacitors don't necessarily read the moment you connect the probes. They have to charge. So depending on the rating of the capacitor, sometimes it takes a few goes to get your capacitance reading. And then down here we've got amps with hertz. Oh, I don't... function I've never used. I'm not sure what the difference would be. Yeah, it is just AC frequency again. I'll have to look in the manual to see what that one means. Okay, as you can see, I haven't got any leads plugged into my system at the moment. These are the standard leads that a meter will come with. As you might be able to see on, let's try and get them in focus, 1000 volts, Cat 3, blah, 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 600 volts, Cat 4. Basically, they're good. They're 10 amp rated at 1000 volts. When they say they're 10 amp rated, there's no fuse in these. They are just insulated probes. If you want to do work and comply with, I think, guidance note 35 or 36 of the HSE guidance, then fuse leads are almost always recommended, unless you're doing particular types of testing, which you wouldn't really do with this meter, because this is, generally for fault finding and investigation rather than doing recorded results and testing. Okay, so to measure voltage, black lead always goes in the middle, that's common, and then for almost all other readings you go into this port, V resistance, sounder, yeah, etc. And then if you're going to do amps, you go into there. Now this multimeter does have a fuse internally. I've never blown it on this model, but I have blown them in the past. So if you ever think you're not getting any readings, or something seems really off, or you've proven your electrical supply with another form of voltage meter, then I would check the fuse in the back. It's normally, again, I don't think I've ever changed it on this, normally under the battery cover. Let's just take the rubberized cover off. So this one's got a nice little stand as well for standing up. Just again, helps you when you're working in awkward situations. So we just would undo that screw, and underneath would be the battery and a fuse. I think you may need to take these screws out. Again, this is not going too deep into a multimeter's function. This is just the basics so you can understand what it's all about. Okay, let's do some basic testing. Black in the middle, head there, fuse is there. Show you resistance first, I guess. So just to prove that, see if our meter is anywhere near calibrated. So it's saying the leads, this is just measuring the leads, the resistance is 0.1 ohms. Sounds sensible to me. Sounds sensible. If we put it on the BP mode, there we go. It's not reading such an accurate reading, but we get a nice little tone. That's great for finding continuity in circuits, etc. Let me grab a battery and we will do some voltage testing. As Big Clive says, one moment please. Oh, let's see if we've got any... So here we are, little rechargeable battery. Let's see if we've got any voltage. Okay, we got 1 point. So this rechargeable battery is actually charged up by the looks of it. Now you might see it's reading minus. That's because we're DC and I've got these around the wrong way. Will you ever get a minus reading on AC? Yes, in some very particular circumstances, but generally measuring it, measuring pole to pole, pole to neutral, or live to neutral, or line to neutral, whichever term you like to use, you probably wouldn't see minus generally. So there we are, 1.27. That's probably could do with a little charge, but generally that is okay. What else can we show you? Let me grab a resistor and I can show you that. One moment please. I won't... Oh. Okay, my little box of bits. Right. I've got some nice large power resistors here. Now I think these are something like 47k, these resistors, or something similar. So let's get a nice connection on there. Obviously a lot of multimeters, and I do have them, they come with crocodile clips, covers for these pins, which you should use when you're measuring higher voltages than sort of batteries and things. Let's just test that. There we are. So 47 ohms, not 47k, just 47 ohms, that resistor. I know you can't quite see the auto readout, but that's basically saying the range is 600. So we're getting 46.8, 46.9, it's 47 ohms. Got lots of these resistors, which I brought for one reason or another and never ended up using a lot of them. That's it, really. The main thing with multimeters is be aware of the fuse inside, buy a good quality one, get fuse leads if you're doing high voltage testing. Really quite simple.